All right, so we're going to try a couple together. These are actually from the textbook. They're from section S of the textbook. This is question 1. This is question 3. This is question 5. That's why you don't have to do them for homework. So the direction says, let's go ahead and find the intervals where these things are concave up, concave down. We're going to go ahead and indicate the points of inflection if they are them. And the way we're going to do that is by finding the second derivative. Okay, so we're going to start with this first one. Looks not like it's not going to be an issue for us to go ahead and find the power rule to find the first derivative. So the first derivative is going to be 4x minus 4. Great, no problem. Second derivative just gets me 4. So 0 equals 4 is not a statement. So this thing is no point of inflection. And before I even started working on this, I should have really looked at the kind of problem I was dealing with, and that could have told me a lot. This is a quadratic, okay, and the leading coefficient is positive, so it means it's a quadratic that opens up, okay? So there is no point of inflection because it goes from infinity in both directions. So the entire thing is concave up. So we will say concave up from negative infinity to positive infinity, okay? It's no point of inflection because I would need a point where the sign changed, which the sign would change except for the fact that I have no place where the second derivative equals 0. All right, so now let's look at the next one. Okay, this one we're again going to do the power rule for. So the first derivative is equal to 3x squared minus 12x plus 12. And I got to get to the second derivative, and I'm going to do the power rule again. So that's 6x minus 12. I'm going to set that equal to 0 because that's going to tell me if I have a point of inflection. So I've got 12 equaling 6x. So x equals 2. Okay, so I know that I've got the second derivative equal to 0 at x equals 2, but the second qualifier to be a point of inflection is that there's a sign change. So let's go ahead and substitute a number that's below 2, like 0, into the second derivative. So 6 times 0 is 0 minus 12 gives us a negative here. This is the second derivative, so I don't forget what I'm doing here. Now I'm going to substitute in the number 3. So 6 times 3 is 18 minus 12 gives us a positive. So in fact, I do have a point of inflection where my x is 2. Why I wrote x right there, I'm not sure. Let's go ahead and fix that, where x is 2. Okay, so x is 2. And to find the y value, I'm going to go ahead and put that 2 back into my original function. So 2 cubed is 8 minus 6 times 2 squared, so that's 24, plus 24, so that just gets me 8. So there's a point of inflection at 2, 8. The second derivative is negative, so that means right there it's concave down. And that's from negative infinity to 2. And the second derivative is positive here, so that's concave up at 2 to positive infinity. All right, now the third one, a little bit more difficult to find the derivatives for because we're going to be dealing with the power rule. I'm sorry, the product rule. We'll see we have 2x as one of our terms and e to the x as our second term. Okay, so take a little bit more space here. I'm going to find the first derivative with u being 2x, which gives me a derivative of u as 2. And v is equal to e to the x. Remember a nice little rule that the derivative of e to the x is e to the x. So my first derivative is going to be 2x times e to the x plus 2 times e to the x. I see a common factor of 2 in both and an e to the x in both. So that's 2e to the x that gets pulled out, and that leaves me with an x on this term and plus 1 on that term. Okay, so to find the second derivative, that was the first derivative. To find the second derivative, u is now going to be, because it's still a product, right? U is going to be 2e to the x. Its derivative is 2e to the x. V is going to be x plus 1, whose derivative is 1. Okay, and so the second derivative is going to be 2e to the x times 1 plus 2e to the x times x plus 1. All right, I see that common factor again of 2e to the x. And when I pull that out, I have 1 plus x plus 1. So I have the second derivative is 2e to the x times x plus 2. All right, so this is the one I want to set equal to 0. So 0 equals 2e to the x, x plus 2. Really don't need to consider this factor equaling 0 because e to the x will never equal 0. Okay, so I really only have to think about x plus 2. When does that equal 0? Well, that equals 0 when x is 2. So I'm going to make my sign diagram for my second derivative with a 2. All right, and if I look at a number like 0, put back into my second derivative, this becomes 2, so it's positive, and that's positive, so that means that's positive. Wait a minute. Oh, that's because that's negative 2. Oof, I put in 0, so that positive is on the wrong side. Ooh, silly little mistake, could have cost me big time there, right? I gotta pay attention better. All right, so that means that positive sign for 0 actually goes over here. All right, so now let's do negative 3. So negative 3, that would just make it go as a numerator, so that would still be a positive, but that would be a negative, which means that's a negative. Okay, so we do have a sign change, and we have a second derivative equal to 0, so that means we have a point of inflection at negative 2, and I've already substituted in negative 2, but you can see if I put in negative 2 up here, this becomes 2 over negative 2 plus 2. That's 0. Would that multiply to 0? Negative 2 over e squared. Where am I getting 4 from? 2 negative 2. I'm getting negative 4 over e squared. Okay, and that says this is concave down from negative infinity to negative 2, and it's concave up from 2 to positive infinity, from negative 2 to positive infinity. Okay, so the next lesson, we're not going to do what we've been doing, which was go on to some IB questions. We're actually going to be doing more out of the textbook. So if you're the kind that works ahead, we're going to keep going, but don't go into anything that says optimization. We're going to save that. And then the week after that, we're actually going to divert from chapter 7 into chapter 14 to look at some derivatives of trig functions. So we're going to save optimization. I think we're going to save that to the beginning of next school year. Okay. I heard from like 2 or 3 of you about some IA ideas. Just remember that when you're talking about your IA, that you have to be able to do your own original math. You're not just going to be talking about somebody else's math, but you're doing your own original math. And it would be, I want to say, it would behoove you to make sure your level of math involved some calculus, and I know right now all we've done is derivatives, but if you can somehow involve calculus into the mathematics that you're going to do, we can ensure that IB will be happy with the level of math that you're doing. The problem when we just start looking at graphs is a lot of times that's just using Algebra 2 mathematics, which is not a high enough level of math. Okay, so keep that in mind when you're thinking about IA topics. I gave you a probable timeline for when that's going to be. It's not that you have to look at it, but some people were starting to have some ideas going on and they wanted to talk about it. So, all right, so I will see you at 1:30 if you're joining me for questions. If not, there'll be the second half of the lesson will come out on Thursday.